Functions and methods are the code equivalent of actions. We have seen quite a few functions and taken advantage of them to print things in our terminal, to collect input from the user, to check the length of a list or a tuple, even to convert a number into a floating point number, for example. Today we will learn how to create our own functions. Let's say when we run the print function, we'd also like to print a sequence of hash signs to separate each output on the terminal from the other one in a more explicit way. Therefore, I can create a function to do that. Python doesn't have one yet, and I can choose a name off the top of my head. In this case, I'll choose print hashes. In order to create a function, I need to use the keyword def for define. Then I'll write the function's name. And in the parentheses, I'll name however many parameters that this function is going to take in order for it to operate successfully. In this case, I'll take in one argument, which I'll call it text, but it can be any data type at this point. It can be a number, it can be a string, can even be a data structure like a list. If I run this code now, you can see here in the terminal that nothing actually happens because the only thing that I've done so far is actually define this function. I've told Python that this now exists, but I'm not telling it to run the function yet. For something to happen, I need to call our function. And when people say call a function, they mean to execute it or to run it. So in order to do that, I'll write print hashes, and then in my function here, you can say that whatever I use as a parameter is going to be printed out in between hash signs. So I'll type in a string here, hello world, and let me run the code. And as you can see here, the function is executed. Python is run top to bottom. So the flow of this code here is first is going to see that I'm defining here a new function. It's going to check what it does. And then lastly, it's going to see that here I'm calling my function with these parameters. So it's going to climb back to the function's definition and it's going to execute it. So you can think about it this way. If I call the function before its definition and I run the code, you can see that print hashes is not defined because I'm calling it before Python has had the chance to go over what this function actually does. So let me bring it back to the way it was. And you might have thought, well, the print function that we've been using, like here, for example, it's not defined in this code, right? And the reason for that is that the print function is a built-in function in Python, whereas print hashes is what we call user-defined because I just created it now. Well, what if we want to use a user-defined function instead of one that is built in? What if a friend of mine created some code that I want to use? Well, I hate to give you this answer, but we're going to talk about how to import those libraries into our code in a future video. Now, let me tell you about recursive functions. Well, recursion is when something happens in itself. So a recursive function is a function that calls itself. And when you hear that, you might be thinking, well, then this should go on eternally in a loop, right? But with some logic, we can prevent that. Let me give you an example of a recursive function. So as you can see, we define a function that takes in the parameter x, and it can be any variable, any data type we would like. So here, if x is bigger than 4, this function is going to return true. And we haven't talked about the return keyword so far, so I'll take a sec to explain it. This keyword, it breaks out of the function and it yields something. In this case, the result of this function as a whole, if x is bigger than 4, is true. Just to give you some contrast, when you cast a data structure to a list, for example, the list function returns a list. This function here would return true. if this condition is met and it yields a true statement. Now, if x is smaller than 4, we keep going. We print the value of x. We increase the value of x by 1. And then after we increase the value of x by 1, we call the same function again, meaning this function is being called inside of itself, and therefore it is a recursive function. Let me give you an example and run this code. So let's say I'll call the recursive function, I'll pass x as 0. When I run the code, you can see here that it prints 0, 1, 2, 3, 4, and then it stops. So x bigger than 4, return true. So it stops there, it doesn't print anything else. So let me take you through the flow of this code when I call the recursive function with a value of 0 as a parameter. So first, it's going to check if x is bigger than 4, which is not because it's a 0, then this does not happen in this case. So we go over to the else, we print x, print 0, as you can see here, increase x by 1, and start over because we're calling this again. So it's similar to a loop in that sense. Then x is equal to 1. If 1 is bigger than 4, it's not, this is not run, and we keep going until this condition is actually true, which means after x becomes 5, we return true and we do not print 5. And then this return keyword breaks the flow of this execution out of this function. Recursive functions as a whole are good to use when a problem can be broken down into smaller, repetitive problems. The last thing we're going to talk about today are lambda functions, also known as anonymous functions. Lambda functions should be used when you know you don't expect to use this functionality more than once or twice. The way to create a lambda function is like this. So first, I'm just assigning to a variable that I just created the whole function. I'm going to use the lambda keyword to define this as a lambda function. Next are going to be all the variables that I'm going to use in this function. They can be more than one. And then the operation that this function is going to perform. So in this case, I'm just taking one variable x, and I want this function to return x squared. So when I print the calling of this variable with the number 5 as x, I want to see 25, which is 5 squared. And now, like I said, you can have multiple variables in this operation. So let me just do x squared plus y. And then when I call this variable, it needs two parameters. The first one will be in x, the second one being y. So let me do 5 squared plus 3. There I have it, 28. Again, you will only create a lambda function on operations that you don't expect to use very often. Because of that, the work of creating a full function is not really worth it. Now, there are some staple problems in the life of every programmer that they need to solve, like the first Hello World program, which you have already done, or the Caesar cipher, which you have not. Another one is the printing of the Fibonacci sequence with a recursive function. So create a program that collects a number from the user and prints the Fibonacci number at that position of the sequence. And just a reminder, the Fibonacci sequence starts with a 0 and then 1, then all the next numbers are the sum of the previous two numbers. So it goes like this, 0 and 1, and then 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and so on and so forth. It goes on infinitely. So create your own recursive function, try to solve this problem, and I'll show you the solution that I came up with in a sec. Okay, so if you managed to do that, congratulations. This is not such an easy problem, but it's good that you're getting some practice. So the way that I would do that, let me just first collect the number from the user, and I'll do that with the input function. What number? And I'll have to cast all of this to an integer because the result of the input function is a string. So let me create my function and I'll call it fib for Fibonacci. I want to get one parameter from the user. And then if the n that the user is giving me is smaller or equal to 1, then I will return n. And then if not, I will just return the sum of the two previous numbers. And just a reminder, you don't need an else condition. If this is not met, then this is just going to happen, because if this is met, the return keyword here is going to bring the n as the output of this function, and then nothing else is going to go on. So here I just have to print the calling of this function, and as a parameter I'll pass in the variable that the user, or I'll pass in the number that the user typed in on the prompt. So let me run this function, and the number that I'm first going to check is number 7, which is 13. And then the next number, I'll just run this again, should be 13 plus 8. So I'll ask for position 8, and then it should be 21. So that was it for today. Thank you for watching, and I'll see you next time.